the Fibonacci numbers given to us and we want to prove this equality. So note that this time the Fibonacci numbers are starting from 1, so f of 0 is 1, not 0 like we had in some previous problem. Okay, so we are given the hint to use, which is this combinatorial equality, and we can prove this property by induction. So for the induction, first we consider the base case. We are using strong induction. So for the base case, f of 0, if we want to use the property, is 1 choose 0, sorry, f of 0 is 0 choose 0, 0 choose 0, which is 1, because we know that 0 factorial is 1. So it is true for this case, and f of 1 is, so n is 1, so is 1 choose 0 plus 0 choose 1. So by convention we know that n choose m is 0 if m is greater than n. So this term is 0 and 1 choose 0 is 1. So f of 0 is 1, f of 1 is 0. It's true for the base cases. Now let's assume that for all natural numbers that are less than n, like m, which are less than n, so for up to m minus 1, the property holds, or this equality holds. Now we want to prove it for n. Holds. Okay, for n, f of n, we know that is f of n minus 1 plus f of n minus 2, and by the assumption of induction, I can write f of n minus down as summation from 0 to n minus 1 of n minus 1 minus k choose k, plus for fn minus 2, I can write again by assumption of induction the summation from 0 to n minus 2 k n minus 2 minus k. Okay, so here we use a little trick that we separate the first term in the first sum in this sum. So we take the first term out, which is n minus 1 choose 0, plus we write down the rest of the summation, the terms in the first summation, which is sum from 1 to n minus 1 of n minus 1 minus k choose k. And for the second summation, we use another trick to basically change the index of summation. Instead of summing k from 0 to n minus 2, I sum some k prime from 1 to n minus 1, and we can change the terms accordingly. Instead of k, I have, so here we can see that k is basically k prime plus 1. So if k changes from 0 to n minus 2, k prime changes from 1 to n minus 1, and we can have n minus 1 minus k prime choose k prime minus 1. Okay, now I gather the terms of these two summations into one summation. So let me erase this base case. Okay, so it will be equal to the first term n minus 1 choose 0 plus the summation. I use the same variable k from 1 to n minus 1 of, so the first one is n minus 1 minus k choose k plus n minus 1 minus k choose k minus 1. Okay, here we use the property in the hint that this is actually nothing by the summation, sorry, this is nothing but n minus k choose k. Okay, so this is equal to n minus 1 choose 0 plus summation k from 1 to n minus 1 n minus k choose k. And now considering this term also in the summation, we have summation k from 0 to n sorry, k from 0 to n minus 1 of k n minus k choose k. Okay, but we can add the term n 0 choose n because we know that by convention this term is 0, so this gives us the summation k from 0 to n n minus k choose k, and this completes our proof for the induction.